Welcome back. Today we're going to continue with our quadrilaterals and logic that we didn't finish last week. So let's get to it. 42. Identify the biconditional for the following statement. If M is the midpoint of AB, then AM is congruent to MB. So remember, every time we say biconditional, we're looking for an if and only if. Okay, I see an only if here, but we don't have an if and only if. Here we do have an if and only if. This is an actual conditional, so I know my answer is gonna be C. Now, let's make sure that's true. I know it's gonna be C because the one that have an if and only if, but I say M is the midpoint of AB if and only if AM is equivalent to MB. That's true. That's the same that it says here, including an if and only if between the two. So yeah. Which figure can serve as a counterexample to the conjecture below? If one pair of opposite sides of a quadrilateral is parallel, then the quadrilateral is a parallelogram. Okay, counterexample is basically how to say that is wrong. So before before thinking of anything, I have a quadrilateral like this. I know this side is parallel to this side, but this is not parallel to this. This is a trapezoid. So this will be a counterexample of the claim that is one pair is parallel, then it is a parallelogram. And for a parallelogram, both needs to be you know, both opposite sides needs to be parallel. So here I can say that my answer is trapezoid, because in a trapezoid there is only one. It is not a parallelogram, and there is only one part that is one part of opposite sides that are congruent that are parallel. In a rectangle, this side is parallel to this one, and this side is parallel to this one. In a rhombus, basically the same. This one with this one, and then this one with this one. And in a square, again, the opposite sides are parallel to each other. So the only one that we have left is the trapezoid. Now, let's see 44. Which of the options best describe a counterexample to the assertion below? Okay, counterexample, we are trying to prove it wrong. So let's say, how can we prove it wrong? Two lines in a plane always intersect in exactly one point. Okay, two lines in a plane always intersect in exactly one point. Okay, coplanar lines is just two random lines in the same plane. Parallel lines, they are parallel to each other. Okay, let's first. Coplanar lines intersect at one point. Okay, parallel lines do not intersect at all. They keep going and going and going without intersecting anything. Okay, I like these perpendicular lines. They intersect exactly one point, and intersecting lines, they also intersect exactly one point. So the only one that does not fulfill this condition for saying in a certain way are parallel lines, because they never intersect to each other with each other. So 45 will be a counterexample. Okay, again, we're trying to prove it wrong. So alternate interior angles are never supplementary. Okay. A line that is parallel to two parallel lines. So a line that is parallel to two parallel lines will be something like this. They do not even intercept, so there are no there are not alternate interior angles there. So nope. A transversal that form 45 angle degree with two parallel lines. I have this, a transversal. This 45, this 45. And when I add them together, like, add them together, 45 plus 45 is 90. And supplementary states that they are 180 degrees. The addition is 180 degrees, not 90. This will be complementary. So it is not B either. No, no. A transversal that is perpendicular with two parallel lines. So transversal that is perpendicular to parallel lines. So this is 90. This is 90. 90 per 90 is 180. So yeah, this is our answer. And now let's check D. A line that has a slope that is reciprocal of the slope of the two parallel lines. Now, if it would have said reciprocal and opposite, then it will be true. But since it's only reciprocal, like for example, this has a slope of 1. A reciprocal of this slope will be 1. Because reciprocal just means flip. So 1 over, okay. If I flip 1 over 1, it's 1 over 1. Like if this, for example, have a slope of um 1 over 2, this is slope 1 over 2 and I flip it, then my slope will be 2 and the line will be something like this. Which obviously the supplementary angles are not going to add to 180. It needs to be reciprocal and opposite to be perpendicular, so no. 36. Which of the options best describe a counterexample to a section below? A game that's all the counterexample means. If one pair of opposite sides of a quadrilateral is congruent, okay, one pair of opposite sides of a quadrilateral is congruent, then the quadrilateral is a parallelogram. Okay, let's see. We have an isosceles trapezoid, which this side is congruent to this side. Basically is, first of all, is a trapezoid parallelogram? But was like, well, it is not. This part is this side is congruent to this side, but these two sides are not congruent to each other. So yeah, that's basically the answer. But if we check the others, oops. Okay, let me keep that one. For a rectangle is a parallelogram. The opposite sides are parallel to each other. I'm trying to do a rectangle. Okay. And this one is parallel to this one, and this one is parallel to this one. A rhombus, again, it is a parallelogram. Parallel, 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 parallel. Then a square is also a parallelogram. This one is parallel to this one, and then this one is parallel to this one. So it leaves us with the isosceles trapezoid. Now, again, another counterexample. So the circumcenter of a triangle is always inside the triangle. Okay, let's see. The circumcenter is the point of congruency. Okay, let's keep reading. I actually have no have like any negative thought about that one, but neither have a positive one. So B, the circumcenter is the point where perpendicular bisectors of a triangle intersect. The circumcenter of an obtuse triangle is outside the triangle. The circumcenter of an equilateral triangle is inside the triangle. Okay. First, we're trying to prove this is false, that it's not always inside the triangle. So I can take this one out because it's saying that it is inside. So we're trying to prove that it's outside. Here, they never mention anything about being outside. And here, they also never mention anything about being outside. And also, the circumcenter is of a triangle is the line that is perpendicular, a line that passes that is perpendicular to the other one. So here, something like this. And then this one will be something like this. More or less. But it is not a bisector. It's perpendicular, but it's not bisector. So that one is actually false. That's actually fake. And now C is our answer. This is true of an obtuse triangle. If we're doing this, for example, okay, let me make it here. The circumcenter for this side will be something like here. Then we'll continue, you know. Then for this side will be something like here. And that's how, because we need to continue the line like that. This will be perpendicular, and this will be perpendicular. And this right here will be the circumcenter. Now, 48. Identify a counterexample for the following definition. If a figure is a polygon, then it has 4 sides. Okay, polygon just means more than 2 sides. That's what it means. Rectangle has 4 sides, rhombus has 4 sides, square has 4 sides, triangle has 4 sides, it has 3 sides. So, what is the only one that doesn't have 4 sides? Easy, triangle. That's our answer. Because we're trying to prove that all polygon has 4 sides. We're trying to prove that it's fake that all polygon has 4 sides. So, basically, the only one that doesn't have one, that doesn't have 4. Next. Mercedes makes the following conjecture. If a polygon has sides that are all congruent, then the polygon is square. Okay, let's see. We have the following as a counterexample that prove this conjecture to be false. Now, an isosceles trapezoid. In an isosceles trapezoid, all the sides are not congruent. This is an isosceles trapezoid, this one is congruent to this one, but this one is different. So, this is wrong. Isosceles triangle. This one is congruent to this one, but this one is different. So wrong. Scalene triangle, all are different. So nope. An equilateral triangle, all sides are equal. Oops, this is the sign for parallel. So all sides are equal, and it does not have it is not a square. So this is the one we're looking for. Now, 50. In the diagram, okay, this is the last question. So, in the diagram below, M is parallel to M. Use the diagram to select a pair of angles that serve as a counterexample to the given. If a pair of angles is congruent, then the angle are corresponding angles. So, first, let's see 1 and 2. 1 and 2, they are not even congruent, they add up to 100 degrees because they are supplementary. 1 and 5, they are corresponding, the F. So they're corresponding, they are not a counterexample. 5 and 7, they are vertex angles. They are congruent and they are not supplementary. So this is your answer. And then 5 and 6, again, they are not congruent, they just add up to 180 degrees. They are supplementary. Now, okay. If a pair of angles is supplementary, then the angles are consecutive interior angles. So, 1 and 2, they are consecutive they are not consecutive interior angles, but they are supplementary. They are just, line pair angles. So they are both over the same line. So yeah, like we just saw our answer. Now let's check the other. 1 and 5, they are corresponding angles. They are not even supplementary. And 5 and 7, they are vertical angles. Now what we're looking for. 5 and 8, Okay. They are also 1 and 2 and 5 and 8. They are also supplementary and they are not consecutive interior angles, because consecutive interior angle will be, 6 and 3 or 5 and 4. So yeah, this is weird. They are both right answers. I think there might be a problem or in the question or in the answer choices. Now let's just keep going. If a pair of angles is supplementary, then the angles form a linear pair. These two are linear pairs, the one that we said before. Let's see which of these are not linear pairs. So 1 and 2, they are both over the same line, so no. 1 and 3, they are not even supplementary, they are equal to each other. 3 and 6, okay. These are consecutive interior angles. They are supplementary and they are not in a linear pair. The linear pair for 6 will be 7 or 5. The linear pair for 3 will be 2 or 4, because those are the ones that are right next to them. So this is an answer for us. And then 3 and 7, they are corresponding angles. They are equal to each other. They are not even supplementary. So yeah, that's basically the answers. Now I'll open the next notes, package number 5, and we will continue with a new topic. So welcome back. Here's the new topic, which is congruence and similarity. Let's see. So they say that a triangle EFG is congruent to triangle JKL. So in congruency and similarity, the order of the letters matter. So I know that EF is going to be congruent to JK. I know that if FG is going to be congruent to KL. And I know that GE is going to be congruent to LJ because of the order of the letters. Now, I'm looking for KL. KL goes with GF, and since they are congruent, they need to be equal, so KL is also equal 6. Wait. Now, in the diagram below, PQR is congruent to JKL. Find the values of X, Y, and Z. Okay, so P goes with J, so P goes with J. Q goes with K. Then L goes with R. So X equals 40. Then Z equals 65. Yeah, we got the answer is B. Now, how to make sure we have this 40. So 65 plus 40 plus Q, which is gonna be Y, equal 180. 65 plus 4 is 105 plus Y equal 180. I should start 105 from both sides. I get that Y equals 75, which is what they say. Also, if you they don't understand, I just associated, because of the color. So I have P as blue, so P is the first letter. make it even smaller. So B goes with J. Then I have R goes with L. And then Q goes with K. So they are need to be congruent to each other because of the order. Now let's say number 3. In the diagram below, triangle ABC is congruent to triangle DFG. Okay, select all true statements. So let's see that. So A goes with D, B goes with F, and then C goes with G. So F equals 35. First of all, X equals 35. Now, we know that this size is gonna be congruent to this size, so this size is 11. And then this size is congruent to this one, so this one is 12. So they are asking for angle D. We cannot prove that the measure of angle D. And they are asking for angle G. Angle G is not equal to 35 because for it to be equal to 35, there will need to be an isosceles triangle. And this side is 11 and this one is 12. So they are different and it is not an isosceles triangle. And then I can say that AB equal 11. Yeah, AB is equal 11. And then DG equal 12. Yeah, DG is equal 12. So we did it here and here. So continue. In the diagram below, ABCD is congruent to DCB, so all true statements. So let's check this. A goes with D, so A is also equal to 120. B goes with C, so this is also 40. And then B goes with C. Now, the opposite side, we know that this side, okay, this side is gonna be equal to this side, and then this side is going to be equal to this side. So first they're asking for x. So since these two sides are congruent, I'm just gonna solve for x. So 2x, 2x plus 3 equal 3x plus 5. So I multiply 2 times x to x, 2 times 3 is 6, equal to x plus 5, 3x plus 5. So I subtract 2x from both sides, and I subtract 5. And this cancels here, this cancels here. I have 6 minus 5, 1, equal 3 minus 2, 1, so equal x. So A is true, B it is not. Now AC equal 10. AC, let's see that. So we have that the x equal 1, so 3 times 1 plus 5, 3 times 1 is 3. 3 plus 5 equal 8. So AC equal 8. So no. Now ABC, ABC congruent to CBD, that's fake. So this one is not congruent to this one. Now ACB, the yellow one, congruent to CVD, which is also yellow one in your diagram. So we know they are congruent. Continue. Number 5. Triangle ERT is congruent to triangle CBD. So first, let me do the diagrams. So I have this triangle. I'm gonna make them in black. So this triangle and this triangle. Great. So this is E R. I'm gonna keep doing it in black. So E R T and C B V. So I know that E is congruent to Z, R congruent to V because of the order of the letter, and then T congruent to V. So the measure of E is 32. So I can say that the measure of C is also 32. Now the measure of angle C is equal 7x plus 4. And the measure of B is 15x plus 15 plus 7. 15x plus 7. Okay, let me make this yellow. Whoa. Wait. 15x plus 7. Now let's solve for x. We established that E is congruent to C, and C is also 7x plus 4. So I know that 7x plus 4 is going to be equal to 32. So I subtract 4 from both sides. It cancels, so 7x equal 28. And when I divide by 7, it's cancelled, and 28 divided by 7 is 4. So x equals 4. That way, to know the measure of b, we need to calculate large b. So b large. So I'm going to substitute my value of x. I'm going to say 15 times 4 plus 7. 15 is 15 times 4 is 60. 60 plus 7, 67. So this angle is 67. So now 32 plus 67 plus v equal 180, because all the interior angle of a triangle add up to 180 degrees. So 32 plus 67 is 99. So 99 plus v equal 180. And subtract 99 both sides. So 180 minus 99 is 81. So answer is 81. Now 6. If triangle ABC is congruent to triangle STF, okay, let's first draw the triangles. We do not have the triangles, so let's draw them. Oops. So I have triangle one here. Actually, to make it easier, nah, it's gonna go a lot. So you draw the triangle here, and the other triangle here. Okay, this is A, B, C, C, S, D, F. So A is congruent to S, and A is 3x plus 5, and S is 1.5x plus 17. And then B is congruent to D, and B is, okay, like here, 5x minus 9. And then, yeah, that's all the things we have, and they say find B. So first, let's solve for x. We have A is congruent to S, so 3x plus 5 is going to be congruent to 1.5x plus 17. So I'm going to add 1.5x, subtract, 1.5x to both sides, and subtract 5. So this cancels and this cancels here. Now 3x minus 1.5x is just 1.5x. 17 minus 5 is 12. And when we divide, so we divide by 1.5 in both sides. And if I'm not mistaken, x equals 4. But let me check. 12 divided by 1.5. Oops. 8. That's the importance of checking. So x equals 8. Now we have that b is 5x minus 9. So we substitute the value. So it will be, let me do here. 5 times 8 minus 9. 5 times 8, 40. 40 minus 1, 31. So b equal 31. Now, number 7 is going to be the last one for today. So let's do it. Find the length of US. So we are missing US. Given that P congruent to S and the length of PQ is 20. So as you can see here, they are actually marked as well. The sides are equal. We can see that PQ is congruent to TS. So I can say that 20 with the length of PQ is going to be congruent to 2x plus 8, which is the length of TS. So based on that, I can solve for x. So I subtract 8 from both sides. This cancels here, and 20 minus 8 is 12. So 12 equal to x. And when I divide by 2, I get that x equals 6, because 12 divided by 2 is 6. Now I can just substitute my value. So 3 times 6 minus 4. 3 times 6 is 18. And 18 minus 4 is going to be equal to 14. And that's our answer. So yeah, that's all for today. We'll continue next week. This one is a little large, so it's going to take us a lot of time basically. So I'll see you guys next week. Bye.